You can say hello if you'd like.
Huh. Hey!
All right, we're ready for our next one on equivalent rates. So today we're going to be deciding if two rates are equal or equivalent to each other. So go ahead and start your notes. Get your title up top. Our learning target, 6RP3, understanding ratio concepts and ratio reasoning. And then our I can statement. I can decide if two rates are equivalent to each other. When you have all that jotted down, go ahead and hit play again and we'll go on with the rest.
Here we go. We've got four sets of equivalent rates here, and we know they're equivalent because they all are set with an equal sign between them. What we're going to be finding is figuring out what the question mark is. And what we want to find is relationships between numerators or denominators that can give us a clue as to what the relationship would be with the one with the missing number. So in our first one here, we have 12 over 60 question mark, 12 25ths over 60 question marks. If I'm looking for a relationship between 12 and 60, I know my 12z's, and I know 5 times 12 is 60, which means my denominator also has to be times 5, and 5 times 25 is $1.25 or 125.
So let's try another one. This time, we look for the pair of numbers that we know both of. We know both denominators. So we look at 16, and how could we transform that into 48? Well, 16 times 3 gives me 48. So up top, we have to think about what's my missing number? Something times 3 gives me 9. Well, that missing number must be 3. 3 times 3 gives me 9. Remember, just like simplifying fractions, you have to treat numerator and denominator the same.
So on our bottom left, we have a 35 over question mark, and that 35 becomes a 7. I know that 35 divided by 5 would be 7. So now the question becomes, what divided by 5 would be 5? Well, I know that's 25, because 5 times 5 is 25.
All right, last one. This one's a little trickier. We want to go from 8 over 12 to something over 30. So we look at the two numbers we know, 12 to 30. There's nothing very easy about going from a 12 to a 30. So we have to kind of find another way of attacking this problem. Notice how 8 twelfths could be simplified. Those both numbers could be divided by 4. So 8 twelfths simplifies to be 2 thirds. Now look at our denominators. Can I take a 3 and turn it into a 30? Well, I can multiply times 10. So I can do the same thing to my numerator. 2 times 10 gives me 20. So sometimes if you can't find a direct way to get there, think about possibly simplifying the fraction, and that can help you find that pattern there. Now we're going to put those equivalent rates or equivalent fractions to use in our problem today.
So there's two ways we can determine if two rates or ratios are equivalent. So make sure you get this down, and then as soon as you get it down, you can rejoin us. If you needed to pause, welcome back. So for number one, we can see if we can transform one rate into the other. And for example, what we have here is three free throws made versus 7 attempts to 7 attempts, and 9 free throws made to 14 attempts. And the question is, exactly, are they equivalent? So what you can check to see is what is the transformation between the numerators and the transformation between the denominators. The 3 becomes a 9 by multiplying by 3. So we know 3 times 3 is 9. The 7 would become a 14 by multiplying by 2. 2 times 7 is 14. So are those equivalent, times 3 and times 2? Nope, they're not equivalent. So what we find out is that those two ratios are not equivalent.
All right, so that's one way of figuring out if something is equivalent or not. Looking for that pattern between numerators and denominators and deciding if they are the same. But another way to do it is just to turn them into unit rates, something we've done a lot of practice with in class. So jot down this one, and we're going to try the second method here. And the reason we have a different method is to get from 20 to 45, there's no nice way of going from 20 to 45. Same thing with 5 to 9. So rather than going between fractions, we're going to deal with each one of them individually. 20 miles over 5 hours. To turn into a unit rate, we divide by our denominator. So I get 4 miles per hour. Do the same thing to our other one. 45 miles in 9 hours, so I divide by my denominator, and I get 5 miles per hour. So now we decide, is 4 miles per hour equal to 5 miles per hour? Obviously, that's not the case. So we would say, no, these two rates are not equivalent. If we'd gotten the exact same unit rate, we know that they're equal. Since we got something different, we know they are not equal or not equivalent.
So here's our first example, and probably setup is the most important key here. So let's set them up as two fractions. We'll have 96 words over 3 minutes. And we'll set that equal to, with a question mark? Do we want to put a question mark?
I'll put a question mark.
Perfect. 160 words over 5 minutes. So we're keeping our units matched in the numerator and denominator, words to words, minutes to minutes. First thing I would check is the simpler numbers is a relationship between 3 and 5. There isn't a simple one. So let's figure out the unit rates of both. So if I do some simple side math, what I see is 96 divided by 3. We would divide the top and bottom by the denominator. 96 divided by 3 is 32 words. 3 divided by 3 is 1. So it's 32 words per minute. Then 160 divided by 5 is 32. 32 words. 5 minutes divided by 5 is 1 minute, meaning 32 words per minute. And what we discover is we do have equivalent rates or ratios. So yes, check mark.
So we got the same unit rate, so we know that those two are equivalent to each other. So let's try another one. 16 points scored in 4 games, 48 points scored in 8 games. We want to see, are they scoring points at the same rate? Are those equivalent? So we write them as rates. 16 points in 4 games. We want to know, is that equivalent to, is that equal to 48 points in 8 games? So we simply write each of them as a rate. Now, in the last problem, Mr. Romanovich's first step was comparing numerators and denominators. Look for that easy pattern first. So we'll try that again. To get from a 4 to an 8, I can do that. I simply multiply times 2. So now I'll check, can I use the same method, the same rate, to go from 16 to 48? Unfortunately, 16 times 3 gives me 48. So my two rates did not change the same, or my numerators and denominators did not change equally. So this one is a no. They are not equivalent.
Nope.
I could have changed them into unit rates. That's always going to work for you. But in this case, there was a quicker way to get there. Finding a pattern between my numerators and my denominators.
Okay, here's our challenge problem. So pause this, do the problem, then unpause it, and see if you get it right.
I hope they paused it.
I don't know.
All right, so here's how I would set it up. 12 juice, or 12 bottles. Oh, I forgot my magic rule.
What are we doing here?
Always put the money on top.
Money on top.
So $4 for 12 juice. We want to know, is that equivalent to $7 for 21 juice? Okay. So there are a couple ways of getting to this one. First way is checking for our patterns. Is there an easy way to go from a 4 to a 7 or a 12 to a 21? No, not really. So what would I divide both 4 and 12 by to turn this one into a unit rate?
We divide it by 12.
So we divide by 12.
And we're finding out the price of 1 bottle of juice.
So our price should be 33 cents. It's going to give you 0.333333 repeating. So 33 cents per juice. Over here, we would divide them both by
21.
21 again. Divide by our denominator. Remember, that's why we have calculators to help with the decimals. And we get 33 cents per juice.
Who knew?
Since they both have the same unit rate, we would say yes, those two are equal. So there's a couple different ways of finding those answers, but think through each problem and how to attack it. Each one's going to have its own little way of getting there.